Okay, so we're going to talk about the main building blocks next. But before we start that, what I want to do is I want to run a application that I have here. I'm going to run it on the emulator, and I just want to show you how it works as a motivation for what we're going to talk about next. So I'm waiting for it to. Alright, so this is a little application that what it does is it simulates, it's like a little Twitter application, right? So just to kind of give you information about this, so, you know, I always had like, I needed the sample app to kind of do show in class so that you can kind of learn constructs by working on something. So I used to have different applications, like I had like a list of restaurants at one point. I had a golf caddy application. You know, just get all sorts of different apps. But and then I settled for the Twitter-like application, and the reason for that is twofold. For one, it's an application that in a natural way showcases a lot of different things in Android. So it's kind of very simple to explain a lot of different constructs all through one application, right? It touches a lot of domains. So it's not just heavy on graphics or just heavy on database or just heavy on networking and so on. Like at one point, one of my first applications was like a Sudoku game, right? So it was heavy on graphics, but very little on everything else, right? So that's partially why I like it. So it covers, it's a very broad reach. Secondly, it's very simple to understand. A lot of people know what Twitter is, so I don't have to explain, you know, unlike like Golf Caddy, I need to explain how, you know, what golf score is. Not everyone gets it. So it's almost perfect, except it doesn't work in certain places like China, for example. That's the only downside, or some extent, or some corporate networks because of the firewall. So. So first time I ran it, it asked me for username and password, and I'm gonna type in learning Android, and password is PASS 2010. So now I have a username and password. So what I want to show you is multiple features of this application. So this first feature is a screen that says, you know, I call it a preference screen. That's where you type in your preferences, like your username, password, some other stuff. Okay. Now I go back to the previous screen, which is the timeline, right? This is supposed to tell me what my friends are doing, but right now it's blank. So that's because we don't have our service running, which is updating this stuff in the background. So if everything works fine, we are hopefully going to connect to the network and pull the data. And we did. Okay, so you can see all the data that you know, people have posted using this application. Now, what I can do, so this is a second screen. It's called the timeline screen, timeline activity, right? I can also go and I can say update status, and I can submit some data out to the cloud. So I can say hello from building C. Okay, and click on update. Alright, so if everything worked fine, this actually went online. So we can check that. Now, just a kind of like a little reminder, I'm not actually using Twitter for this. I'm using a service that's just like Twitter. In other words, implements the same API, but it's not twitter.com. The reason for that is that you know, when I do a class like this and everyone uses my same account, and it's like 20-30 of us hitting the same account, really quickly Twitter shuts us down, thinking that it's a denial of service or something that's abusing system and so on. So I went ahead and I set up a separate account on a status.net, which is a company that makes the Twitter-like API. So you can see that this is the same thing, right? And here's our post, hello from building C, right? Make sense? And you know, and eventually when you go back to that timeline and when it refreshes, I'm not sure exactly what the frequency of my service is, but it updates every once in a while, and there's hello from building C. So far so good. So you you saw 3 screens. There's something running in the background, etc., etc. And it makes a network call and updates data and so on. Okay, so with that, what we're going to talk about is some main building blocks. What main building blocks are basically components that are specific to Android. Okay. So one of the first things you notice is something called activities. What an activity roughly is a screen, right? That's what we just said. So you kind of saw a couple of activities in that previous example. You saw the one where I was able to update my status. So that was a status update, and it posted it to the cloud. You saw another one where I was able to list all my statuses for my friends. I call that one timeline. And then there was the one where I was able to update my username, password, possibly some other information. Okay. So these are activities. So one application can have multiple activities, multiple screens. Just like I compare it sometimes to a website. Just like a website can have multiple web pages, right? You usually have what's called a home page or the main activity. It's like the one that you enter through, right? That would be the home one. Okay. So that's about it. Make sense? Roughly one screen, right? So one thing that you need to know about activities is that their life cycle is heavily managed by the system. So there's a specific life cycle, and activities adhere to that specific life cycle. So at the beginning of the day, your activity doesn't exist. So it's in a starting mode, okay? So it doesn't exist, just starting. As it starts, it's in what we call a running state, okay? That means that it's up and running, it's in user's face, it's interacting with the user. How many activities can we have running at one time? One. Yeah, only one can be interacting with the user at one point in time, right? Now you may have some activities which are visible but not in focus. It's kind of behind the other activity, right? It's kind of, you can still see it, but it's not in focus. That we call a paused activity. Okay, it means it's visible but not active. Okay, or running. Now, if an activity is totally invisible, so it's totally obscure, hidden, it's in a stop state. Right? So typically an activity is going to go into running, and from there it's going to go pause, but really quickly it's going to go into stop state. Okay, that's pretty normal. Now from stop, it may get restarted if the user goes back to that activity, or it may get destroyed. That's a typical life cycle of an activity. Right? So it would, it would normally be this, then this, then multiple times that, and then at some point it would come out. Sort of like that.
So why not from running to stop?
Okay, that's a great question. Why not go this way? Why not go directly from running to stop? Okay. Why not go from running to stop like this? Well, we could do that as well. Designers of this system could have done that as well, but that would just mean that you have to figure out the logic then if you're going to pause or stop right away. So it just turns out that there isn't really a good reason to go that way. In other words, going this way doesn't really make that much of a difference, but makes the life cycle simpler, because you know that these methods are going to get called every single time, even though they may not do much. Right? So it's simpler to implement it this way. Right? It just goes directly, it goes to paused. Now, being in pause, go to pause, that just means, okay, somebody invoked some callbacks and they did nothing. So it doesn't add any overhead, right? Whereas figuring out which way to go would actually be adding overhead.
Does the stop free up all the resource or not?
Does stop free up a resource? No, it doesn't free up a resource.
Only destroy will free up.
Yes, only destroy would free up a resource. So why not just go this? Why not just go from running to destroy, like iPhone does, for example?
But then, because Android allow you to resume, if you put something, you run an activity, and you go to another one, you can go back to that one from the same place. And if you just destroy always, you need to save like a form that was partially entered or something like that.
Yes, exactly. So it turns out that going from here to here is actually pretty. Let me draw it like this. So this here is pretty costly, right? So there's a lot of work that needs to happen to go from starting to running. Okay. So if you think about it, if our activity doesn't exist, we may have to create a new Linux process. We may have to launch a new Dalvik instance. We may have to load that new Java object, parse its XML and create entire UI, then draw that UI on the screen. So there's a lot of expensive steps, right, in getting something to show on the screen. Now, once it's on a screen and user doesn't want it anymore, goes away from that screen, as opposed to just destroying it, we keep it around in this stop state. So that if a user wants to go back to it, user can go back this way, and this just happens to be much cheaper than going from starting to running, right? So that's basically why we're keeping it around, thinking that if a user wants to come back to it, it's readily available.
So what exactly is the difference between paused and stopped again?
So paused means it's slightly visible, whereas stopped is not visible at all.
So you're looking on a screen, what do you mean slightly visible? You see it in the background?
Yes, exactly. It may be like a dialog box opened up, and you can still see the stuff behind. It's a rare state, especially on a small screens. Like it's not something we typically see, but it is possible. Right? So usually that's why you just kind of like you fly through that state and you go into stopped. That's how it usually works in practice.
These events are they called before that happens? Like on create is called because is it possible to stop and go back or stop?
You as a user do not control the state. So you as a user do not get to say, okay, be stopped, be paused, be destroyed. Right? You as and not as a user, as a programmer, as an application programmer.
But we get to call those methods, right?
The methods get called by the system. You get to fill in the blanks. Right? So this is, have you guys ever programmed in any other container-based environment like servlets, applets, scriptlets, any of those sorts of things, where you're basically filling in the blanks. Something else is calling your code. It's a fundamentally different approach than like C programmer, right? It's kind of like event-driven. You're filling in the blanks for what should happen when that event happens.
So in essence, if you have, let's say, two activities, right, 1 and 2,
Right.
if you're in 1, 2 is behind number 1, so it's not visible at that
Right.
point. So at that point, you're in an on-pause state, right? So then you can call 2 to come in front of 1, then it comes back to on resume, or?
Yeah, so it's if it's totally not visible, it will be actually in stop, not on paused, right? So let's demonstrate this. Go ahead.
Sorry. So when you're starting it up, you have an on create, on start, and stuff, right?
Yeah.
So why would I put something different in an on create as opposed to an on restore instance state? If I say, okay, on create is what I want you to do for this activity. Maybe talk to this website, blah blah blah, log in or do something on create. And okay, on start I understand you need it when you stop and start again, maybe you remember some cookies on it. What's on restore instance state? What state are you restoring?
So on restore instance state is not that used that often. It has to do with when your application is dying and getting recreated really quickly. It usually happens when you change the orientation of the screen. And it's a way to leave something for yourself while you reincarnate really quickly.
Which means I didn't die, I stopped and I started back?
Yeah, exactly.
But then I stopped and went to running or started?
Well, let me ask you. Let me ask you this. Let's kind of let's look at this graphically. So right now, what activity is running? So timeline activity. So this guy is now in a running state, right? I'm gonna click on back. Oh, okay. I love the entire thing. Now that one is stopped. So it just went right. It went from running. It went here into stopped. Okay. Now let me see if I can get back to it this way. I can say back there. Okay. Now it's running again, right? So if I go menu and I say preferences, now that one is stopped. This one is running, right? So they change, right? So you know, one is in here, the other one is in. You can have multiple activities be stopped. You all usually do. Okay. So that's what that means to like flip flop between activities.
Right. No, my question was more about what instant state will you say when you're starting a new app? You know,
Yeah. So
when an activity starts new, it's new. I mean, if there's no state there, right? Because otherwise, it would go from stop to running if you save the state.
from stop to run. Well, what happened? So on stop, save instance states and on restore instance state is only applicable to changes in the orientation.
So every time I think the orientation is actually getting completely
Essentially,
stop,
yeah, exactly. It runs. It pretty much runs a destroy on it.
Oh really?
Yeah,
Wow.
yeah.
Just the orientation?
Yeah, that's the default behavior. Of course, you can change that, but that's the default behavior. It basically recreates the entire screen. Yeah, so it's kind of pricey. But let's take let's look at the resume, for example, as another example. So let me ask you this. For example, this state running. The name says you're doing something, right? You're running. Some code is running, but in reality, it could be that you're just sitting in that state waiting for some user input, right? So in reality, a running state doesn't mean you're doing much. Maybe you're doing nothing yet. Okay?
You've rendered your page at that point.
Yeah, you're just maybe sitting there doing nothing. On the flip side, stopped doesn't mean that you are necessarily not doing anything, right? So for example, if my application is listening to GPS or is processing sensor input, it's doing a lot of work, although it's not visible, right? So running doesn't mean it's working, and stop doesn't mean it's not working.
Oh, but it's still called stop, even
Yes.
though in the back end it's getting updates.
Yeah, that's just a name. So that's why it's kind of confusing. That's why I wanted to point out that that's just a name.
The GPS thing that you mentioned is kind of a service.
Right. But if you're listening to it, you're keeping the channel open. You're basically activating the service.
So it's more like kind of visible and hidden.
Hmm?
It's running, visible, and stop hidden.
Yes, that's exactly what it means. However, you know, just because the words imply doing something and not doing something, what I'm trying to say is that that's not necessarily true. So if you take a GPS as an example, so GPS is expensive, right? Listening to GPS involves a lot of battery consumption and so on. So when would you like to be listening to GPS? How would you construct your app so that it listens to GPS only when you need it? So you want it only working while in that state, right? Okay. So where would you turn it on? Where would you turn it off?
On resume.
Okay. So on resume is a good place to turn it on because all the roads into running lead via on resume. Right? And then on pause is the good place to turn it off because everything that goes out of from running goes through on pause, right? Make sense?
Does it mean the application need to have those control states?
Well, you get to override or implement any of those methods that you want. You don't have to, but if you want to do some code that always happens just before we go into running, on resume is a good place. Right?
So how about if application or either activity get the error exception? How does it work? It's going to run it and then pause and then destroy? Or?
That's why I have this, it could be that it's just a process kill, like depends on an exception, but it's very unlikely, but this can happen, like you can just kill the process. Like it's just gone.
If your program has a multiple activity, if one of that activity get the error exception, how does it bouncing to the other activity say stop? So never destroy. How does it ripple effect?
So if one dies, then the activity manager then picks up the previous one from the stack. So there's something called activity manager that manages all this. It's a background process that manages all the activities.
It's per process.
And it's a background process. Yeah. So does that make sense?
So if I go on the shell and I do yes, do I see my each activity listed as a separate process?
So that's an interesting thing. You don't see activities, you see applications. So if I do adb-e shell ps, what I'm seeing is I'm seeing all the applications. So there's my application, right? And I could do kill 400.
Yeah.
Let's see. So right now it's running. Right now it disappeared, but it's for some reason it got restarted. So now if I do ls, ps, so now it's 417, so it got restarted.
You as a developer cannot clear an application, right?
Yeah, no.
The OS has to do it.
You can kind of say I want to terminate it, and then it's up to the system to actually acknowledge it and do it.
So what restarted your app just now when you came?
Application manager.
Oh.
Yeah.
So now I know it's the 33 process specific. What is 33?
So that's the user ID.
Okay. So if I'm looking for memory and CPU, I'm thinking at an app level and not like per activity inside the app level, right?
Yeah.
If I want to know, which is the page that's killing me, I wouldn't know it from PS yet.
Yeah. So this is basically the CPU utilization and all that stuff.
Right.
But it's on the app level. It's not on activity level. Yeah.
So I have some other tools.
Yeah.
So let's say you start an application, so you launch one activity, and that represents the application. So we're doing simple case. The application is just
Hello world.
One activity.
Uh-huh.
Now you back out to that to the main screen. The application is still running. It's there still. It's not been killed or destroyed.
Yeah.
So I go to some other application and I run some activities in there, and I come back out of that. If I don't go back to my Hello World application, at some point the system will
Kill the activity, and once there's an application without not anything running in it, it kills that application as well when it's not needed. So application exists as long as one of its components exists. Yeah.
And the components can be only activities or is there something else?
No, that's one of the 4 things that it can be. So we're gonna look at some other ones as well. Yeah.
So in that case, when you killed it at the command prompt, why did the application manager start it again? So
Why did it do that?
yeah,
That's just how it's designed.
okay.
So it basically, it's not supposed to just die. It's kind of weird to just, have it crash.
So in a real life scenario, when you have a physical device, for some reason, if it gets killed, the application manager needs to change.
Yeah. And the idea is that to a user, it doesn't matter if we got into here this way, okay, or this way. to a user, that's pretty much a very similar experience. You know, it just one way may take a little longer time than the other way.
So the OS can kill it at its own discretion, basically.
Exactly.
If you don't have it open and you're not, interacting with it.
Exactly. Exactly. It's up to the system to just wipe it out whenever it feels like it.
Can we kill the application manager?
Hmm?
Can we kill the application manager?
What would kill the application manager?
Yeah, just kill it and you won't launch again.
Well, yes, but except the init system is gonna restart it. Yeah, you can kill it, but the init system is designed so that it keeps it running. It's part of Linux.
So you said the application manager can change at its discretion.
Yeah.
Does it mean that if there are too many stopped activities and you need some space, kill it?
Yeah. So basically, who would you give priority or dedicate memory to?
Almost call related stuff.
Okay, call related stuff. What about the state?
Or state.
The running, yeah. So the one that's running basically has all the power in the world, right? That's the one that we are going to give, the right to all the memory, everything that it needs. Yeah. So everyone else is basically subject to.
So how would the state maintain the stop process?
That's the system service. That's the system service. It's always running.
My question was, if the activity is stopped, the state is preserved, right?
If activity is stopped, yes, because it's still loaded in memory.
And if the application manager kills it and will it restart it at some point in time when it has more resources and it recovers the state?
Yes, it can recover the state. If it's stopped, then just restarts it. So the state is recovered from memory. If it's starting and the state was not saved or anything like that, then it just starts it up as if it's a brand new activity.
My question is when some activity gets booted out with priority queues,
Mm-hmm.
and if that was in a stop state when it was killed, and would it restart it when suppose the call has gone in there? Would this be restarted again by the application manager, and if so, would the state be recovered?
So if it was restarted, if it went into destroyed, and then it's restarted, it would start from scratch. But if it was stopped still and then restarted, it would restart from there. So that's why sometimes you go back to previous application. It just remembers a lot of stuff about like the last phone call that you were making or the last map location you were looking at and so on. But sometimes it doesn't, so it just starts from scratch. Yeah.
In the stop state, let's say if your application is have some network connectivity to the remote side,
Mm-hmm.
does the stop state still keep those activity? I mean, the connectivity is still alive, or
Yes. Yeah.
so even something like TCP alive or something, it will still re-add those packets. Or?
Yeah. And that's the problem, because the stopped doesn't mean necessarily not doing anything,
Okay.
right? So just like running doesn't mean necessarily that it's doing much, right? Is that kind of making sense?
So
Yeah.
usually running is more like for the presentation room.
Yes. So yeah, so the names are a little misleading, but that's that's about it. Yeah. Yeah. Cool. So I mean, we'll be coming back to this diagram multiple times. There's just so many layers of kind of understanding it. So just so you know. Okay, so let's talk about something else. So one of the next things that we have is something called an intent. So basically what an intent is sort of a way to message between two parts of the system. and essentially creates a concept of a task, like a user is doing a task. So for example, maybe on one screen, I want to go to the next screen, and then I want to go to the next screen. Like I want to read my email, then I want to click on a link, open up a web browser, then from a web browser I'm going to SMS the client or something like that. So you can do 4 or 5 things as a user, one after another. And that creates sort of a task. But the way we jump between things or message between things is via something called intents. Okay? So kind of 2 things to remember about intents is they can be sort of implicit or explicit. So what an implicit intent would be, what an explicit intent would be saying, I want to start such and such application, for example. So for example, I sent you an email and I say, hey, click on this map. And you click on it and it opens up Google Maps or it opens up Yahoo Maps or something like that. Depending on what it opened up was if it was spelled out how to handle it, right? So if I say open up timeline activity, then there's no question which timeline activity to open. So for example, if I'm here, or now I'm already in timeline activity, but if I'm, okay, hold on, go back to that application. So if I go, for example, here, and if I say go to status update, there's only one status update, so it knows which one to open up. But if I have multiple possibilities, then they can compete for the same action. And that's an implicit sort of intent, okay? So I'll give you an example of that. How many of you still use Internet Explorer? It's okay.
Using Cisco.
Okay, so but a lot of people have replaced it with something else, right? Like you guys downloaded like Chrome or Safari or Firefox or something, right? So basically, if I send you a link and I say, hey, go to open up this web page, it's going to open up Chrome or Safari or Firefox for you, not necessarily Internet Explorer, right? That's because you essentially replaced it with another application. Or at least you replace the handling of that request, right? So check this out. So if I press the home button, okay, it opens up an application called Home, right? See, it's got some buttons at the bottom and so on. Now there's a sample Home application that ships with Android, and I just want to show you really quickly. Okay. So it's installing it, it's installed, it's done. But I don't see anything. Why not?
Service.
It's a service? Well, Home is a special kind of application. It actually responds to this button right here. Right? Or you can see it. It responds to this button right here. Where's my... Let me click on Home. And all that button does is actually it launches the Home application, launches an intent. But see, now when I pressed it, it says, okay, which one? Because me now have competing actions. Right? So I can now say launch it using the launcher, which is the default application. Right? Or I can say launch it using Home sample. And notice how long it's taken to start. 2, 3, 4, 5, 6. Took a while to get started, right? But this is now an alternative version of a Home screen, right? It's got, see, the icons at the bottom, and this opens differently, and so on. So, I can go back to my Home. See how now it remembers where we were previously in this one. But see, if I press Home now again, oops, and I say a sample again. So check this out. 1, 2. See how, bam, it just started. That's because now Home started from stop state as opposed to from starting state. So explicit would be saying, like, for example, in here, if I say menu timeline activity, I'm explicit by what I mean timeline activity. I'm not saying, oh, start somebody who's capable of being a timeline activity. It's not meant to be replaceable. It's not meant to be for user to define a third-party activity. Right? I'm explicit. I'm saying start Internet Explorer, not a web browser. Right? Being very specific about it. So far, so good. Okay. So that's intent. We'll be using quite a bit of them. Okay. So the next thing that we have is something called services. So service is basically just like activity, but it runs in the background and it doesn't have any UI. Okay. So I have music player here as an example. So if I had a music player, then I would have an activity that asks me which song, and then offers me play button and so on. But then the actual playing would happen on a separate, in a separate something, and that separate something is called a service. So we have another component that's running the actual playing of the service.
How does the activity communicate with the service?
So that's a good question. How does the activity communicate with the service? Well, it can do two ways. One way would be to basically say start and stop a service, and in that case, our service is what's called an unbound service. So in other words, the life cycle of this guy is different than the life cycle of this guy. So what that means is that our music player graphics UI could start and disappear. Right? But our music is going to keep on playing. So their life cycles are different, are separate. Okay? Versus if we had these two bound, then the life cycle is the same. And what that means is that, but on the flip side, this guy can tell much more stuff to this guy. He can say not just start, stop, but it can say rewind, look for the artist, like, unlike certain song, and so on and so on.
Can multiple activities talk to the same service?
Yes, multiple activities can talk to the same service. So far, so good? Questions on service? Okay, so then service life cycle is much simpler. It's start, stop, destroy pretty much. So you don't, it's not as managed by the system. The idea is that the services are not as complex, right, as activities are. So they're not as expensive and such are not as managed by the system. Right? A user can see this running services by going into this. I'm going to tell it not to ask me again. Okay, so the user can go into menu, settings, applications, and then under running services, you can basically see what is currently running on this.
Why do you
Why do you care to know that? Good question. Maybe you as a user want to shut down a certain service, right? Like I may have a service that's tracking me, a cheating spouse service, right? It's a common one, right? That's actually tracking, where you're at and maybe sending your location back and forth. You may have a service that's just taking too much. Yeah.
No, my question is if I get the service from here, and then if I go to the activity, it's going to start back the service. All I'm doing is run the service. When I kill it, I'm killing it forever. When I'm killing it, when there's no associated activity.
It may or may not be associated with it. So, what do you guys have? Somebody tell me, what services do you have running on your phones?
We have something looking for Wi-Fi
Yeah, okay. I mean, I'll tell you what I have on a physical.
Update something.
Yeah, I have Download Manager, I have Skype service, I have Twitter service, I have Google Voice, I have Luminescence, which is the 3D, yeah, the wallpaper. I have DM service, which I don't know, Swipe, SNS, Gtalk, and SNS photo service. It's a whole bunch of services. So you may just, decide that you don't like a service. It's a service that's just wasting your CPU power or something, and you just want.
So my question is, why do you have a GitHub service running when you're not actually trying to talk? What does that mean?
So why would you have a Gtalk service running when you're not connected to Gtalk? So that's going to be exactly the reason why we're going to have a service running even before we are ever using Twitter account. That's because maybe its job is to periodically goes online and pull some data. Right?
It's not visible at the point, but it could be a helper in the background.
Yeah, it could be doing something. Maybe it's monitoring my power consumption and deciding to, turn off power at certain points in time, like dim the screen, turn off Wi-Fi to extend my battery life.
Or something like Gtalk, even though you're not in the Gtalk application, because of the presence application, somebody else somewhere else will see you as online.
Exactly.
So you're there. So
Exactly.
not just when you're in the application.
Yeah.
But that's what you
Yeah. Poll is a common example. So it's doing some kind of polling, like going online and polling some kind of data.
Does the HR platform support the push model?
There is a simulated push. It's something called device to cloud to device messaging. C2 and DM. Yeah. I'll talk about that at some point.
But email system is a polling or push?
Well, Gmail uses that technology, but normally you would do poll. Yeah, which is not ideal at all. So that makes sense? Okay, content providers. So content providers is basically a way to have two applications share the data between themselves. Okay, so let me see if I can draw something. It's basically an interface. So here's how things look like on your device. So I may have one app, and I draw applications as like this, like a silo, right? So it's got its own Dalvik, and so on, right? So it's a separate application. And typically, let's say it's an address book, right? So I would have an activity. So this would be my UI, and then I would have the database with all the data, right? So this would be one way to design your address book, right? So you have a UI, you have data. Now the problem is, what if I want to have a third-party application access this data? Like for example, what if my Twitter app wanted to see all the people that I have in my address book and then go online and so forth and so forth. So this would mean that I would probably have to recreate another copy of the data. So I would have multiple copies of the same data, which is not a good strategy, right? So the better strategy would be to do something like the eraser thingy. Oh, maybe that's what you use. Okay, so another approach would be to do something like this. To have a second application actually own the data, right? And then expose that data via this API back to the client. So basically, you're splitting this into two separate applications. one responsible for the data itself, the other one is responsible for viewing the data, right? And if you do it like that, then you could have another application that taps into the same sort of data set, right? Maybe this is another UI, and it also uses the same data, right? So that's exactly how a system does a lot of stuff. So for example, you know, anybody has Sense UI, HTC Sense UI on the phone? You know how like HTC address book is much nicer looking, right? But you also have the original Android address book. And same for calendar, right? Because they're both tapping to the same data source, they just present the data in two separate ways, right? Media store is another example. Like I may snap a photo with a camera, but that photo is then available via the media store both to my email if I want to email it, to my wallpaper if I want to put it on a wallpaper, and so on and so on. Right? So that's kind of how we're basically separating those two concerns.
So this is an external storage system. Let's say if the storage system is over the cloud, is it possible?
So this is internal storage system, right? So
Yeah,
this is
over the cloud.
if it's over the cloud, you would have to deal with that. But let me rephrase this. This so far is just an interface how to pierce the hole between one app and another. It is typically backed by a database. And that's why this API is very, very similar to the database API. It becomes sort of like a one-to-one mapping. It becomes a simple proxy. But it doesn't have to be that way. It could be that data actually lives in a cloud, so that when you're, when you're doing this, actually, you're connecting via this interface, right? But the actual data is somewhere behind the cloud. It could be like this, right? So this is my content provider, but and nobody else cares about that, right? So that's kind of the nice design because nobody cares, and you can easily change how the actual implementation of that looks like. So that's what the content provider is.
So they are using the key value store system for the engine, and the storage and the key value.
Yeah, it's basically very similar to SQL, right? And then you can look it up based on a key, a unique key.
And unless I have multiple consumers of the content, there's no real value in pulling it out, right? Out of that particular application.
There's no real value in putting it out.
Pull it out as a content provider rather than integrate it with your acquisition.
If you do not have, that's correct. So if you do not have multiple users, there's no real value in exposing it to others.
Not optimizing everything.
Yeah. Yeah. But for example, you guys on a CS, you may have a separate, support for multiple users. Right? So that's kind of like a platform-specific functionality that you may want to, provide. So.
What do you mean when you say multiple users?
I think one of the projects on CS is to be able to log in so that I can take a device and I can log in as myself, or like you can do on your PC. Android doesn't support that right now, right? So.
But that would just mean taking that login information and doing some validation with some authentication service and then coming back, right? Why is that? That's just one extra call before you get into the screen. Is that something more than that?
Well, that's just authentication, but what about the authorization? All right, so now Bobby logged in so is Bobby going to have the same data and same applications and same rights as Tommy? Yeah, so it's actually, you have to now split. It's actually a pretty big deal to split all that, provide a true user management. Because Linux in itself already has user management and Android does use that. Now we're creating a meta kind of user management on top of that, so it's kind
why wouldn't you tap into the Linux users?
Well, I don't know how they're going to implement it. You could do that, but you already have, and they just mean certain things. So for one user, we already use a whole bunch of Linux UIDs, right? So that's, it's not clear.
For the content storage in the Android, do they support the, let's say, is it all in memory or all in, will be, say, some is in the memory, some is in the persistent storage, or?
It depends on how you implement it. So like I said, this is just an interface,
Okay.
and typically it's backed by a database. So typically it's just using a database behind the scenes. But it could be going to a cloud. It could be
Yeah.
stored in memory. It could be a file system. It could be any of the number of things.
But
Yeah.
all the API is there, right? Is already provide all the API, and something is in the memory, something is in the storage system, something like Flash, or something in the cloud. Is built in or ready to have our own library or something?
You will need to support it yourself, but the database already has a certain support for it. So there's a built-in database with built-in support for a bunch of stuff. So far, so good. You typically, as an app developer, you don't develop too much content providers. You usually use existing ones. So that's kind of how it works.
So how do you share data between two activities in the same network?
How do you share the data between two activities? It really depends. It really depends on what kind of data and what kind of sharing. You can do everything from, keep joking, but you can do everything from like sending pigeons around to like smoke signals. There's different ways to share the data, right? You can always open up a socket, right? You can always like leave stuff on a file system, right? But those are not very elegant approaches.
I mean more like passing database.
Yeah. Well, again, you could do it via socket, via pigeons, via file system. But there are many ways, like in any traditional approach. However, there are two ways that are sort of more Android specific. It's a good question. One way is we sort of already discussed, and that's the intents, right? So intent is a form of communication. I can actually attach data and pass. So as opposed to using a pigeon, I can use an intent. It's a little more intelligent, and it's good in certain situations. That's one way. So using an intent. Another way to pass the data would be to use IPC mechanism, a binder. And they have their advantages and disadvantages. The biggest one is that one is asynchronous, the other one is synchronous. Right, so
Intent is more or less asynchronous, or
Hmm?
intent is more or less asynchronous?
no, intent is actually not asynchronous. So when you make an intent, you're just dropping it somewhere. You just say, "Oh, I would like to do something," bang, and you're done. You just leave that on some kind of queue to be done at some future point in time. So it's very asynchronous. Where a binder IPC mechanism is actually asynchronous. I mean synchronous. So it's basically blocking on that call. So you say, "I want to do something," and you're waiting there for that something to do. Right?
So intent will send back the response, and if you have a request, that you send back the response back to the caller?
Well,
Or necessary?
Intents have a primitive way of sending the data and reading this response. So there is some kind of mechanism for that. But the way I like to compare intents to URLs, to doing a get in URL. So just like if you can put some data in the URL, but it's very limited and it's very rudimentary. So similarly, intents has something called extras. You can attach a bundle of data to an intent, and it's basically name-value pairs.
But as a caller, you can, somebody who's sending the input, I don't know if it actually got executed. I have no return values.
Yes, you do not have a way to know that it actually got executed. It's asynchronous. Yeah.
So can simple intent point have multiple event or so you can combine.
Yeah, in intent could be a broadcast intent. So you can just go top of the mountain and hey, something happened, right? So that's a type of an intent that's called a broadcast intent, and it actually kind of leads into what we're talking about next, which is broadcast receivers. So the receivers of broadcast intents are broadcast receivers, right? So it's essentially a publish subscribe mechanism. So if you have if I have some kind of piece of code that wants to register with the system to get some kind of notification. So by registering, I could say, for example, I want to know when the battery is running low, or I want to know when SMS arrives, or I want to know when the phone rings, or I want to know any of that sort of stuff. The system notifies you then when that something happens.
So
Right.
would you register that only with the system or with any of the services?
It doesn't have to be just with the system. It could be with any other component in your system. It could be with your examples as well. Yes, but it's basically a publish subscribe. You register and then you get notified when that something happens.
Like maybe the like 2 minutes icon at the top would be something that is simple.
Yeah, it doesn't. It's not visual, right? But it's just it could be a broadcast saying, hey, something happened. Now it's up to for somebody to receive that and actually do something with it, right? So far good? Okay. So those are the main building blocks. Those are the components that we have in the system. So back to our example application, that application that you saw, which used to be called MyTwitter, but since it's not Twitter based, now it's called Yamba, which stands for yet another microblogging application. So if you want to, so remember this app. So here's how I designed it as an example of how it could be designed. Hold on. So we have 3 screens, right? We have 3 screens. This is the screen where I update my status, right? It's got a field. It's got a button. You type in a button, and whoop, it goes and puts it on somewhere on the cloud via web service. So far, so good? So that's the piece, we're going to do that today, right? So we're going to create a screen, you're going to type something in, you're going to click on a button, and you're going to go and check online that it actually happened. That's what I like about this example as well, that we can organically grow it like step by step, and every single time you can actually see that it's working. So you're not going to wait till Friday to get, well, this is instant gratification. You're like, okay, it's great, it's working, right? So we'll be able to basically create this screen. On this screen, we're going to be able to type something in, click on update, and we're then going to be able to go here and make sure it actually worked.
So the menu options for each page, what are they? So are they other activities or are they called intents?
Well, this thing, this is what you're talking about?
Mm.
That is just something called options menu. It's a UI thing.
Oh.
Now, what it does is up to you. And in this case, I think all of these are actually something intents. Yes. Yeah. Okay, so back to the picture. So that's the screen where you say what's up and you update the cloud. Now we have another screen where we get to configure our username and password and any other type of preferences, and that actually has a way of storing that information on a file system, right? So it stores it on a file system, and because multiple parts of the system need username, password, and other sort of common stuff, right? So that's what preferences is. Finally, I need a screen to show what all my friends are doing. Okay, and I have a way, or I could have done it like this. So this screen could have went to the cloud and just read the data. But we don't do it that way. Why? What's bad with that approach?
You get everything again. You don't know where to start. You only just one increment.
Okay, so incremental's the problem. Okay, what else? Okay, security.
It wouldn't seem as smooth because with a service doing poll in the background, when you go to the screen, you'll see most things are there. And maybe if one or two come in, that's fine. But when you just click on it and go poll, you have to wait. You don't know how long. It's not deterministic. It seems sloppy.
Yeah.
Using the application.
Yeah, exactly. So I think you know the network latency is a big deal, right? So if I had to wait every single time to see what my friends are doing, you know, it'd be kind of slow. Plus, you know, I usually use this app when I'm on a plane or I'm in a subway, places where I don't have network connection, right? So as opposed to doing that, okay, what I opted to do is to basically have a service that keeps cranking in the background. It's always on, always running. And every so often it goes and says, is there something new? Is there something new? Is there something new? And so it pulls from online service and then inserts that into the database. So next time around, when I want to see what my friends are doing, I can just look straight through the database and it's instant. So it's much faster and smoother, although may not be the most up to date.
So back to that preference that I said no, there's nothing is username and password because this is multiple
Yeah.
apps to use it.
Yeah.
So basically every page I go to, is it actually logging back every time, or is it keep remembering the session and using the same session across?
It's using the same session across in this example. So it doesn't have to re-log in every single time between pages.
And how did you do that again? How does it remember who passes the session across?
We're going to use something called an application object. So we're going to use something that's common to all these guys to share the data.
Oh.
Which is a good question. So one thing that I wanted to point out, what is application here? Well, everything here is an application. Everything you see, well, not the cloud. The cloud is sort of cloud. But everything else is the app. So this is our application. So as you can see, application is a whole collection, a whole bunch of different things that we, you know, keep in the same place. So,
So, say for instance, the first page and it said they log in, and you probably got a session ID, and you store that session ID somewhere else for all the subsequent pages. Is that what you're doing here? Or for our service to use, or I'm just curious how does the session to your cloud work?
Yeah, you'll see that, but it's going to be shared by, it's going to be a shared object that all these guys have access to.
Because that's pretty much what I was thinking for my network management application too. So I'm wondering, you know, ideally, what we have web services, I can call my web services API, but then that returns me a session ID that I need to remember for all my future communications.
Yeah.
So how would I pass it?
Yeah. So in this case, we're going to be storing it in an application object, which, you know, I guess you got a good point. I don't have displayed that object here. It's not a bubble, but it is an object that basically everything in this sort of, you know, round thing uses.
So I can create common objects like that multiple apps can go from. So it's like my.
Well, in this case, not multiple apps, but multiple parts of an app.
Oh, okay.
So in this case, I'm talking about multiple parts of the same app. But everything that's within a line is basically one app. Yeah. So that makes sense?
The operator says you starts at loop and keeps running the model all the time.
Yes.
Isn't it battery point of view? Is this how you would design, or you had something specific in mind? You didn't really care about the battery.
Yeah, so I didn't really care about the battery in this case that much. The better approach would be to actually run it still. You would still run it forever, okay? It's just that it should get a little smarter about, first of all, if there's no network connection, like I'm in a plane, it it doesn't make sense. Yeah, it doesn't make sense to even attempt to open up the radio, right? Second approach is to actually pull all the network calls together using something called alarm service. So that's the recommended thing. So basically, if you look at it this way, Gmail, Gtalk, Calendar, they're all doing this every so often. Every so often they wake up, try to do something, and then shut off. Now, waking up a radio and shutting it down is very expensive. I don't know the units, but it goes from like 10 microamperes to like 110 microamperes. So it just like really spikes up and comes down, right? So the much better practice is to group all these network calls to happen on the same sort of peak, right? So right now we're sort of running our own show, and if everyone did it that way, then you have a lot of peaks as opposed to just one, but more.
So when the radio turns on, you want all of them to just get them.
Yeah.
In Android, you can turn off the background services, right? I mean, you can shut it down basically if you conserve the battery, so no application has the right to do anything with background services.
Well, you can do what I showed you guys. You can go and kill services.
You can kill them all. I mean, there's a way to turn off so no application can use the background services.
So there's a way. There's something called disable background data updates or something like that. I forget. But that's really just a suggestion. I forget where it is, but I know what you mean. But that's mostly just a suggestion.
It doesn't do it.
Yeah.
I own a Galaxy and I can do it.
You cannot do it. No, there is.
On my phone, you can. I mean, this basically goes from 5 hours of battery to 2 days of battery. You turn it off, and then nothing will. I mean,
This is it. Background data. Applications can sync, send, and receive data at any time. Okay, so that you can disable. So disabling background data extends battery life and lowers data use. Some applications may still use the background data connections. So in other words, you as an app developer, you should be adhering to those settings, but you can also ignore them. Right? So all this does is it flips the switch and says, don't use background data, or do use background data. We should be checking for this.
so if the developer says if
Forget
off,
it, yeah.
then don't. But
Yeah.
if they don't check, they can still run it.
Yeah.
Oh, that's sad.
It's not like turning off the radio, so you can't
I thought it
control
was a
them.
hard switch. I thought you would stop everything.
Yeah. Yeah. So yeah. But yeah, that extends battery life drastically now.
Drastically,
Yeah. Cool. So is this making sense? How how to use these main building blocks to construct a typical application? Cool. So what we're gonna do is we're gonna basically do an application like this to kind of see how stuff works. Okay. And that's going to be our example application. So you're going to see quite a few different screens. So we're going to have a screen here, a different type of screen here, a different type of screen here. You're going to see how to do a web service call, although we're going to use a third-party library to do that, as opposed to actually do the URL mumbo jumbo, which is not subject of this class. You're going to see how to use the file system. We're going to have a service that runs in the background and does some kind of updates. We're going to have a boot receiver here. We actually have a different kind of boot receiver here. We're going to use a database. We're going to write an adapter. And we're going to do actually a little more to this because we can also plug in location stuff because Twitter supports location. So you can say send from San Jose, for example. We're going to do little audio, so if there's a new message, we can actually also play some audio, and so forth. So those are some ideas that we're actually gonna have. If we have enough, I think we should have enough time, but we can actually hide this behind a content provider. And see, the only thing I did not have here before was content provider. I was like, why would they need it? Like, it's, I tried to stay away from like forcing features just to show something. And then I realized, I can show you guys how widgets work, like as in the home screen widgets. And for that, that's now a third-party application. We can actually provide the content provider so it can tap into the data to show on the screen, like like rotating. Yeah. So that's. I have a newer version of this example than what's on this graph. So we'll add that.
So these receivers are not content providers.
No, they're not. They're broadcast receivers. So the difference is a broadcast receiver is there to publish subscribe. So you subscribe to some event, you get notified. Whereas content providers are for sharing data between apps, right? But this is for sharing data. This is, I want to know all the contacts. I want to know all the gallery photos, right? Versus sending messages, which is what intents are for. Now, yes, you can attach data to those messages, but that's not really meant for sharing data, right? Just like, URL get and put, HTTP get and put, one is for making a request, the other one is for actually sending the data. Although you can kind of cheat with both. So
you have a multiple way to share the data and the other one side is the one.
Yeah. And we'll talk about IPCs later on. They're a little more advanced.
How to create application objects.
Hmm?
You create an application object that everybody accesses.
Yeah, you can do it that way if it's just if it's plain old Java data. Yeah.
The type in this diagram, any print of sequence required, we have so many bubbles here. Yeah. How does the print of sequence for this application? You have the update surface and the print receiver and also the timeline receiver, and you can utilize the boot up sequence and this kind of thing.
Well, the boot up sequence, the startup sequence of these things, this is an application. So it really depends on how a user starts it. So user can either enter, through this screen, or this screen, right? It could enter through, just like you can enter a website to something that's not a home page. This one is going to be running at all times and so on.
So should the update surface running at the beginning, or you need to wait for the data to trace.com to get the access, or starting sequence?
It's going to keep on running forever. So it starts first.
You start first.
Yeah.
But it needs the user input first, right? Doesn't it need like the login information first?
Yes.
The first time you would probably wait until somebody logs in and then it will probably work.
Yeah. In terms of us writing it, we're gonna basically do something like this: 1, 2, 3, 4, 5, 6, 7, 8, 9. So those are roughly our sort of steps. Alright, let's take a short break and then we're gonna jump into the UI and talk about that. Sounds good?